What is OSI? The 7 layers that the computer system employs to interact over a network are described by the Open System Interconnection, or OSI model. It was the first standard model for network communication, adopted by all major computer and telecommunication companies in the early 1980s.
7-layer of OSI model.
Here are the 7 layers of OSI model. The application, presentation, session, transport, network, data link, and physical.
Application layer. It provides protocol that allows software to send and receive information and present meaningful data to user.
Presentation layer. It defines how two devices should encode, encrypt, and compress data so it is received correctly on the other end.
Session layer. It is responsible for opening sessions, ensuring they remain open and functional while data is being transferred, and closing them when communication ends.
Transport layer. Transport layer, it is the responsible for reassembling the segments on the receiving end, turning it back into data that can be used by the session layer.
Network layer uses network addresses, typically Internet Protocol addresses, to route packets to a destination mode.
Data link layer establishes and terminates a connection between two physically connected nodes on a network.
Transport layer prepares application data for transport over the network and processes network data for use by application. Primary responsibilities to accomplish transport layer. Number 1. Tracking the individual communication between application on the source and destination host. Number 2. Segmenting data and managing each piece. Number 3. Reassembling the segment into streams of application data. Number 4. Identifying the different application. Primary function. Segmentation and reassembly. Most networks have a limitation on the amount of data that can be included. Number 1. Connection-oriented conversation. Number 2. Reliable delivery. Number 3. Ordered data reconstruction. And number 4.
Or ACK. It is used to acknowledge packets which are successfully received by the host. The flag is set if the acknowledgement number field contains a valid acknowledgement number.
Push or PSH. Transport layer by default wait for some time for application layer to send enough data equal to maximum segment size, so that the number of the packets transmitted on network minimizes, which is not desirable by some application like interactive application. RST or reset. It is used to terminate the connection if the RST sender feels something is wrong with the TCP connection or that the conversation should not exist. It can get sent from receiver side when packet is sent to particular host that was not expecting it.
Synchronization. It is used in first step of connection establishment phase or three-way handshake process between the two hosts. Only the first packet from sender as well as receiver should have this flag set. This is used for synchronizing sequence number, example, to tell the other end which sequence number they should accept.
Finish or FIN. It is used to request for connection termination when there is no more data from the sender. It requests for connection termination. This is the last packet sent by sender. It frees the reserved resources and gratefully terminate the connection.
Network layer. Communication from host to host. To accomplish this end-to-end transport layer 3, used for basic process. Addressing. The network layer must provide a mechanism for addressing these end devices.
Network layer must provide encapsulation. Not only must the devices be identified with an address, the individual pieces the network layer PDUs must also contain these addresses. During the encapsulation process, Layer 3 receives the Layer 4 PDU and adds a Layer 3 header or label to create the Layer 3 PDU. When referring to the network layer, we call this PDU a packet. When a packet is created, the header must contain, among other information, the address of the host to which it is being sent. This address is referred to as the destination. The Layer 3 header also contains the address of the originating host. This address is called the source address. After the network layer completes its encapsulation process, the packet is sent down to the data link layer to be prepared for transportation over the media.
Routing. The role of the router is to select paths for the direct packets towards.
Decapsulation. The packet arrives at the destination host and is processed at Layer 3. The host examines the destination address to verify that the packet was addressed to this device. If the address is correct, the packet is decapsulated by the network layer at the Layer 4. Contained in the packet is passed up to the appropriate service at transport layer. Unlike the transport layer, which manages the data transport between the process running on each end host, network layer protocol specify the packet structure and processing used to carry the data from one host to another host. Operating without regard to the application data carried in each packet allows the network layer to carry packet for multiple types of communication between multiple hosts.
Internet Protocol version 4. Basic characteristics. Connectionless. No connection is established before sending data packets. Best effort. Unreliable. No overhead is used to guarantee packet delivery. Media independent. Operates independently of the medium carrying the data.
IP source address contains a 32-bit binary value that represents the packet source network layer host address. IP destination address contains a 32-bit binary value that represents the packet destination network layer host address. Time to live (TTL) is 8-bit binary value that indicates the remaining life of the packet. Type of service (TOS) contains an 8-bit binary value that is used to determine the priority of each packet. protocol field enables the network layer to pass data to the appropriate upper layer protocol. Command offset identifies the order in which to place the packet in the record structure.
Now, we're going to discuss the IP network connection data end-to-end.
Routing IP packets. In this diagram, it shows how the routing packets works. First, the desktop computer or the host send the IP packet into the LAN switch. And then, this IP packet will be sent into the other network, which is 192.168.5.0 with the prefix mask 24. And this IP packet will pass through the gateway into the router 1. Is this packet destined for a directly connected device? No, because the packet will forward to the next router. The IP packet arrived to the router 2, but it is not the final destination because it will forward again to the next router, which is the router 3. The router 3 will pass the IP packet into the LAN switch 4. The IP packet arrived to the final network, which is network 192.168.5.0 with the prefix mask 24.